Hi, I'm Brian.
And I'm Harris.
And we're going to teach you about derivatives. Alright, hi. Let's go over the power rule.
Why is the store open?
We're just opening it.
Alright, so the power rule in itself is taking a function and subtracting the exponent by 1 and taking the exponent and bringing it down to the coefficient. Small example. So if we had this and you wanted to find the derivative, you'd bring down the coefficient to this and subtract it by 1. So your end result would be 4 times x to the power 1, or just 4x for simple. Our next problem is still covering the power rule, but just more complicated, but not really because it's easy. So you first have to set up this, because this is very important to your equation, because if you don't make this little line, you're going to miss a mark and get a bad grade on your test. Alright, so we move on to the first. You get your exponent, carry it down to your coefficient, and subtract the exponent by 1. So you're going to have 4 times 4x, 4 minus 1. That's going to be your first step, which is just going to be 16x to the third. Now you move on to your second, which is 7 times x to the third. So you get your 3, carry it down, you're going to get 21 times x, and 3 minus 1 is 2, so that was pretty easy. And we go to the next one, which is 6x squared. So you carry down your 2, you're going to get 12x to the 1, and you don't have to write 1, so don't. And then you have 8x, and you carry down your 1, which is 8, and then you subtract the exponent by 1, which is nothing, so you're just going to be left with 8. Then you have a single digit. And any number by itself is considered a constant. And constants also include pi. And all constants, when you're deriving it, is 0. So your constant's going to be 0, so you can write plus 0, but you're just wasting space. So you don't have to write anything when you're deriving that. And so this would be your final answer to that problem. Boom. Okay, so the quotient rule is simply low derivative of high minus high derivative of low over low squared. So what do I mean by high and low? For example, if we had a problem as x squared over x minus 3, this is high and this is low. So low derivative of high is x minus 3 times the derivative of the high function, which according to the power rule is 2x minus, carry that on, high derivative of low, x squared times derivative of low, which is just nothing, it's 1, over low squared is x minus 3 squared. And I didn't simplify, but you could if you wanted to.
Recording.
Okay, so our next example is f of x equals x over ln of x. Okay, so f prime of x equals, remember the equation we use, low d high minus high d low over low squared. Okay, so low is ln of x times the derivative high, which is 1, minus high x, derivative of low. And so ln of x, the derivative of that is 1 over x. And then we have ln of x squared. And this is a logarithmic function, so we can bring this here. And so our final thing will look like, since this just equals ln of x minus, and then x times 1 over x is 1 over 2 ln of x. That's it. So we're moving on to chain rule. Okay, so our first example, let's go with e to the cosine of negative x. F of x equals, okay. So chain rule is taking the derivative of the outermost function and then working our way inwards. So what do I mean by this? So what's the derivative of e to the cosine of negative x? Well, derivative of e to the x is e to the x. So the first thing we're going to have here is e to the cosine of negative x. But this is going to be times the derivative of this function. And the derivative of cosine is negative sine. So it's going to be negative sine of negative x times the last one, which is negative x, which is negative 1. And if we simplify this, we're going to end up with a positive sign, is e cosine of x times sine negative x.
Oh, they're negative x.
And what's your final answer? Alright, time for more chain rule. Alright, so our next problem is f of x equals e to the e to the e to the e to the e squared. E to the x squared, sorry. Alright, so we begin with our outermost function, f prime of x equals e to the e to the e to the e to the x. Yes. Yeah, squared. Sorry. Times this function, e to the e to the e to the x squared, times this function, e to the e, sorry, it's an e, not an x, x squared, times this function is e to the x squared, then just 2x. Yeah, that's your answer. Tedious, but chain rule. Chain rule. Yes. Each thing is important. They all matter in life. F of x matters. Go. Okay, so now we're going to cover the product rule. Okay, so product rule is pretty much, you have two functions being multiplied together. For example, you have e of x times x. Just call that. Yeah. Okay, so we can label these things 1 or 2, a, b, it doesn't matter. It doesn't. However you like to remember it. And how we would find the derivative of these is we would have a prime times b plus b prime times a, or it could be 1 prime times 2 plus 2 prime times 1. It doesn't matter how you think of it, it's the same thing. Anyway, so a prime, so the derivative of e to the x is e to the x, times just b, which is x, plus b prime, which is 1, times a, which is e to the x, and that's it. Answer. And simplify it a little bit more. E to the x times x plus e to the x. F prime of x equals this. Product rule. Alright, so now we're going to do a fancy problem and or complicated problem. Alright, so this problem's going to encompass several rules. See how we can apply them. Alright, so f of x equals e to the x times x squared all over ln x. Alright, so f prime of x equals, so remember from quotient rule, low d high minus high d low over low squared. So we're going to have our low, which is ln x times derivative of high, and here we're going to apply the product rule, which is e to the x times x squared plus e to the x times 2x, and that's power rule because derivative of x squared is 2x, and then minus, because we're referring back to quotient rule, which derivative of ln x is 1 over x times e to the x times x squared all over low squared ln of x squared. And that's your answer. Well, you can carry down the 2 like we did in another problem. But other than that, it's good. Fancy problem. Okay, so you know the problem we just did, I didn't simplify the top, so don't think this is all. It's right, it's just not simplified. Sorry. Sorry.
Question mark.